All right. Review for the final. Once again, just some general announcements. The final is Tuesday from 4 to 7 in this room in Brevard. Bring pens, pencils, eraser, pencil leads. If you want to bring a ruler, that's okay. Bring green Scantron. Bring your calculator. That's it. I'll provide the test and the extra paper. The test will definitely be 50 multiple choice. It will be 6 problems at 15 points each. So that's 90. 50 multiple choice, 2 points each, that's 100. And then 2 appetizer at 5 points each for a total of 200 points. This final is worth 30% of your total grade. The 50 multiple choice, the majority of which will come from earlier tests. There will be a few just added in because some of the multiple choice are inappropriate or bad or need editing. The 6 problems in the appetizer, just to go over some certain ones that will happen. Vector addition. All Eschenberg students must be able to add vectors. The next thing is Atwood's machine. Could be motion, could be energy. Not sure yet. There will be an inelastic collision. Stuff smacking up against each other, typically sticking, and then there's something to be done. Inelastic collision most likely will be combined with energy.
Are you listing the problems or appetizers right now?
Problems. There will be, just probably going over some stuff that now, appetizer and the other problems, you can have sound, Doppler shift, fluids. Another one that is fairly certain, rotation. Not sure if it's equal to 0 or not equal to 0. We did not equal to 0 in the test, so heavier probability of equaling 0 on the final. (2D) motion. I'd probably put that as a high probability. Torque bar. I mean, we did it before, and I have said that there may not be a right-hand rule game as where there would be like 5 problems, but there may be 1 or 2 in the multiple choice. And if I'm running short on questions, I'll just throw a few of those in there. And so, I mean, it does look pretty simple. Unit conversion. If a unit conversion is in there, it'll be an appetizer. How it typically goes for problem selection, I'll write like a dozen problems, and then I'll look at it and go, all right, these 6 could be done in 2.5 hours. But I would say that these 4 are big deals. with the fifth one being a 2D motion most likely. So it tends to be a little bit more on the heavy side for test 1 and test 2 material. I may try to fix that, but that's the gist, the layout of the final. What we can do now is just answer I'll just answer questions. As a reminder to everyone, please be able to pick up your homework by Monday early evening. On Tuesday, I throw that stuff out. And then we've talked about the finals rule. Don't come see me after the final. SDS students, I'll contact you separately over the weekend. And we'll set up a meeting time to take the test. And I think that's it. So let's get cracking on problems. So who has a problem? Yes?
I had a question real quick. So for the rotation problem, you said you gave us one where alpha doesn't equal 0, right?
Yes. The alpha not equaling 0 was the one that looked like that. The one where it was equaling 0 was the Fisher-Fury problem, which I did on Thursday.
I'm slightly confused on your logic on 5 and 6. Like, basically, an appetizer problem can be the same amount.
No. What the pool of, these are the topics which will likely be appetizer or a main problem. If it's an appetizer problem, then I got to strip it down and be a fairly quick problem. If it's a real problem, a 15-pointer, then it's a little bit more involved. A Fisher-Fury, I could get it to an appetizer or I could make it a problem. The more questions you add to it makes it transition from appetizer to problem.
So all those potentially could be appetizers?
Yeah. How could a Doppler shift be an appetizer? Car approaching you at 50 meters per second on Earth. You hear a tone of 2,000 hertz. What's the tone that the car actually makes? That's an appetizer. The roulette wheel problem, that's a problem. Still using Doppler shifts, but it's a little bit more complex. Fluid, simple buoyancy problem, like the balloon with the string and stuff. I could make that an appetizer. The Bernoulli's equation, that's an appetizer. That's fairly quick. A flow problem, like if you add a tank, or you have to determine the flow of the tank coming into the tube with the Bernoulli, that makes it a problem. Generally, hybrids are real problems, and single subject material is an appetizer. So that is my logic. Let's see. I would say the big things are know your units. If you say energy is in terms of units of energy are newtons, then we got problems. Be able to, you got to use coefficient of kinetic friction for moving objects. If it's not moving, you use static coefficient. So stuff like that. Yes?
Can we do a problem in one of the tests?
Which test? What subject?
Number 4, it's sigma, appetizer 1. I wasn't able to figure that out because the second area wasn't given, so I didn't know how to go.
You mean this? This one?
Okay. On my test, the 0.25 meters.
Oh, yeah. It's, I think one of the versions, this is rho.
Okay, yeah. This is
Yeah. I think when I remember, I didn't give that area and I had to fix it during the final.
So don't worry about that.
I wouldn't worry, no. Adding that makes it easy.
Right.
Yeah. Other questions? Yes?
So since there are like so many problems, do you think it's going to be like really instead of the?
I would say that the rotation one, the thing that I've started doing on a more regular basis is for the rotation problems, even when alpha is 0, still putting in a geometric shape to it. So there could be a stick on it in a various way. There could be masses. So yes,
So like,
it most likely that will make it a legitimate problem is if you add a type of geometry to it. I always thought that those problems were a little bit on the weak side, but changing the geometry makes it legit. A non-trivial geometry. Yes?
we worked in 2D motion problem, but one that wouldn't be an appetizer, one that would be an actual problem.
Yeah, we could do... Oh, we'll do the final problem, sigma, the one with Sykes. So it is hit initially at home plate at 1 meter. It goes up, comes down, and it lands 3 meters, excuse me. And I'll just use Y2 and Y1. Or actually, use the Y naught and Y1. X naught is 0. X1 is 125 meters. The time that it took to fly was 7 seconds. That's necessary to make, if the landing and the launch point are at different heights, I have to give you time to make it non-quadratic. If I give you a flat surface, the launch point and the landing point are the same height, it's definitely not quadratic. And you can still find time. You don't have to be given it. AX is 0, X naught is 0, because it's launching. So X is T V naught cosine theta. Y equals Y naught plus V naught Y T plus 1/2 A T squared. A is -10. Y equals Y naught plus V naught sine theta T plus 1/2 A T squared. Now I need to identify what I know and don't know. Final X, 125. Yes, I do know that. Time is 7. Yes, I do know that. I I don't know V naught or theta. Don't know any of that. I do, however, know initial and final Y, T, A, and T. So this is a 2-equation, 2 unknown problem. The best way to solve for this is X divided by T cosine theta is V naught. Substitute that into here. Y equals Y naught plus T sine theta X over T cosine theta plus 1/2 AT squared. T's cancel, sine over cosine becomes tan. And I'm going to start moving stuff around. Y minus y naught minus 1/2 at squared is equal to x tan theta. So 1 over x, y minus y naught minus 1/2 at squared is equal to tan theta. And then theta is inverse tan 1 over x, y minus y naught minus 1/2 at squared. So plugging stuff in, inverse tan 1 over 125, 3 minus 1 minus 1/2, negative 10, 7 squared. And that gives me, let's see, 2 plus 5 times 49 divided by 125 inverse tan. 63.2 degrees. Now that you have that, the V, which you substituted for, is this. So X is 125, T is 7 cosine 63.2. Oh, hee hee. Sorry, hold on. Cosine of 63.2. .6 meters per second. And that is the velocity. So the 2D motion is a good thing to have a 2 equation 2 unknown experiment on. Yes?
We do problem 6 on the same test.
Problem 6, same test. Okay. Now this is, let's take a look at it. An object as shown has a frequency of 4 hertz. So just the people at home can take a look. It changes its geometry. How long does it take for it to rotate 10 times using its new geometry? What is the ratio L initial over L final? The first part, or this part, just as momentum is conserved in collisions, angular momentum is conserved during these changing of geometry. So L initial is equal to L final. That's the conservation of angular momentum. So L initial divided by L final is 1. In the initial orientation, you had 3 masses where the mass of the point is 1/9 the mass of the disk. The mass of the disk is 70 kilograms. The radius is 6 meters. What I need to do is I need to find the moment of inertia of the system. Which is this. Moments of inertia add just like masses add. Ooh, wait, hold on. So 2,100 kilograms meters squared is the initial moment of inertia. In the final moment of inertia, the radii change. The disk is still the same, but the point particles have a new moment of inertia. The old moment of inertia, well, let's just write this out. 1/2 md r squared plus 3 mass point r prime squared. The new radius is 1/2 of the old. So 1/2, 70. The disk does not change, so that's still 6. But the mass of the points is now 3. And adding all that stuff together, I get 1470 kilograms meters squared. So you have to find the moment of inertia for each of these. In the conservation of angular momentum, Li is equal to Lf, which is also equal to I initial omega initial is equal to I final omega final, because L is equal to I omega. Now converting omega to frequency, 2 pi f is equal to omega. So this is I initial 2 pi f initial is equal to I final 2 pi f final. The final frequency is I initial over I final times the initial frequency. Now I needed to know what the moments of inertia initial over final is. So I initial over I final is 2,100 divided by 1470. And that gives me 1.429 as the ratio. I need to find the new frequency. So the new frequency is 1.429 times 4. So it has a frequency of 5.714 hertz. Now, period is 1 over that final frequency, which means that the period is 0.175 seconds. The question asks, how long will it take to rotate 10 times? Total time is the number of rotations times the period, so 10 times 0.175 or 1.75 seconds. And that's the answer. So for something like this is related to playground physics. In playground physics, in this wheel that we're spinning, angular momentum is conserved. So that's the answer to that. Other questions? Okay.
hertz.
Yes, 5.714 hertz. What I would do in terms of studying, I would look at your notes and videos for review sessions, the lectures this week, the tutorials that we've had. I would then look at all the lecture notes that you've had, be able to go through all of it and understand it. And then only then I would start working on homework problems. The notes tend to be the most beneficial of all your sources. When you look at the Google Drive, there's tons of review sessions. So you can look at the other semesters and look at the last lecture or the last video posted. That's going to be your review session. And that's about it. So if you want, we can keep talking, or it's Friday afternoon, we can do whatever we want. So, and you just get here. So any other questions? Okay, do you have a burning question?
It's fine. Will you put it online?
Yeah, this will be online in about half an hour after it ends.
That's fine.
All right, going once. Yes. 2 questions. Yes.
You can go first.
All right, your question.
You were problem 2 from the last test?
Problem 2 from test 3.
Yes, sir.
Do you have a copy of it?
I did.
So problem 2. Oh, the outward string? This one. Okay. Now the outward string directly will not be on the final. However, sound is on the final, so this is kind of a necessary thing. In the outward string problem, we have a vibrating region L1. The frequency is NV over 2L1. Now the velocity is square root of tension over lambda, the mass per length density. So this becomes N over lambda. The tension is provided by the hanging mass. The lambda is mass of the length divided by the total length. So this becomes Fn over 2L1 square root mass that's hanging times gravity over mass of the string total length. L1 plus L2 would be in the denominator of the denominator, so it gets kicked up to the numerator, and it looks like that. We have a couple of things to substitute in. That L1 is equal to 0.4 meters, and L2 is 4 times L1, or 1.6 meters. Therefore, the total length, L1 plus L2, is 2 meters. The goal of our little game is we have to find out what N is. So, solving for N, F2L1 times the square root of MS over MHG L1 plus L2 is equal to N. L2 comes up. When that goes over there, it flips. So I know what L1, L2, and L1 plus L2 are, but I don't have MS or MH. But what I do have is that MH is 10 to the fourth times ms. And the ms is canceled. So what I'm left with is 1677.05, 2 times 0.4, 1 over 10 to the fourth times 10 times 2. And the number, I did some rounding, and the number is close to 1. Hold on, let me see. Let me do the calculation again. And I get 0.95, which is 1. Let me look at this up in the notes, because I thought that it should have been, these numbers are not, it's definitely not 14.99, what you had.
It should be like 372.
This is, let me give you the version. You can give me what you got. Kenan. What was the answer for Kenan?
I didn't get it right. I got 9s.
Mm.
That's not right.
Would 3 sound right?
Yeah, I think 3 is, let's see, hold on. Let me take a look at what you got. Yeah, 14 is not it. I'll go through these again, but I definitely know that 15 isn't it. Real quick, and this may actually be one of the reasons why this number may be so low. Did anyone get full credit on the Atwood string? Anyone?
Yeah.
You did? Let me see. Let me see.
You have to square you have to square the F.
I just square that.
Don't you? Because you're not.
Oh, I didn't because I kept everything in the square root. But I mean, no, what you did is fine.
I guess I go ahead.
What's your version? Pavilion. Pavilion was 6. Let me go through and square it, and then I'll see what happens. That may have fixed it. Let's take a look. I may be looking at something that isn't. Oh, do you know what it is? I know what it is. Hold on. Let's work at this. F N 2L1 mass hanging gravity L1 plus L2 ms. I'm going to square everything. F squared N squared 4L1 squared mass hanging gravity L1 plus L2 over ms. Solving for n squared F squared 4L1 squared MS MH G L1 plus L2. Let me see, I get this 4L squared MS comes up, MHG L1 plus L2 comes down. And really we get the same in 2L1F square root MS MHG L1 plus L2. I still end up with still get this 2 times 0.4 times 1677.05 square root 1 over 10 to the 4th times 10 times 2. All right, this may be a calculator parenthesis deal. 10 to the 4th times 20 square root that's not. So I still get about 0.95. The only thing different for you was the frequency that you had. What was the frequency that you got?
3,300. Yeah, 3,384.1 inches.
Let me see how that works. The length of L1 was still 0.4, correct?
The 0.4, yeah, and the string was 2.
Okay. I'm still not getting. I'll work on this over the weekend and I'll show you. One of the basic things that's definitely true is that this will not be on the final. Also, the lower, I'm going to double check my answer key, and if I find a problem with it, that's also going to be considered. The average for the class was a 70, and so there will be a curve on this. And it may be because there was a weird number. Let me, just real quick, so I have records. You got full credit, right?
Yeah.
Okay. What I'm going to do is I'm going to take pictures of both of these, and then I'll get back to you.
What are you talking about?
It was like basically 7,200 over like 200,000.
Not sure what it's can, but it'll be substantial.
Really?
At least 3. but it's fine. I'll take word now. There's no sense in spending more time on this. All right, any other questions? Yes?
Can we do the Atlas machine problem 3 on the spring test?
Problem 3? Oh, okay.
I just didn't know how to solve the velocity.
Now for this one, it is equations of energy. In the initial position, the only thing that you have is potential. The work done through friction is that. And you get it because is this. And because the object dropped a distance L, that one moved a distance L, and we have this. Then at the end of the motion, there is no potential energy anywhere in the system. It's all kinetic. 1/2 m1 plus m2 v squared. All the numbers were given except for M1 and M2. They were given as a ratio. So what you do is you have M2 GL minus mu sub K M2 over 5 GL equals 1/2 M1 plus 1/5 M2 plus 1/5 M2. Hold on, let me get a new sheet. And you get this. And simplifying it, so before I do the cancel, I'll write it out. The M2s cancel. So this becomes GL 1 minus mu K over 5. So the GL was factored out of this to get 1. The GL was factored out of this to get mu K over 5. And then 1/5 plus 5/5 is 6/5 or 6/10 V squared. Solving for V, 5 over 3 GL, 1 minus mu sub K over 5 is equal to V squared, or the square root of 5/3 GL, 1 minus mu sub K over 5 square root is V. Plugging the values in, 5/3, 10, L is 2, no, L is 20, 1 minus 0.1 over 5 is equal to V. and this will give you some stuff. (18.07 meters per second). The substitution was the key part in it.
We expect a lot of that on the final, a lot of substitutions.
At least one. There will be one substitution at least. Yes.
I didn't catch what version this was.
What version is this?
This is Sigma.
Which one?
It's
It's blank. It
you gave us.
typically I pull the first one off the page. So all three versions are in each of the packs. So look at the problem set from the first third of the pack, and it should be in there. Okay. Anything else? All done? I will definitely take a look at the Atwood's machine or Atwood string. That will be taken into consideration. I got to look at the answers and see what's going on with that. But officially, it's not going to be on the final. There will be strings on the final. There will be pipes on the final, but not an Atwood string. There will be an Atwood's machine truly in it. All right, going once, going twice. This will be up in about half an hour. Bye.